Would you like to be able to deploy MySQL HA database quickly with a repeatable process that eliminates configuration errors? Hello everyone, my name is David Teague, your friendly neighborhood technical marketing engineer. Deploying a highly available MySQL cluster usually takes hours of tedious manual setup. But in this video, I'll show you how to provision, secure, and configure a complete MySQL HA database in under 15 minutes using NDB. Let's dive in.
Starting on the NDB dashboard, we'll provision a MySQL HA database. To do this, click the main menu dropdown, select Databases, and then click Sources on the left-hand menu. From there, click Provision, select MySQL, and choose HA Instance. On this first screen, we'll define the name of our server cluster and select the specific Nutanix clusters where we want to install MySQL. Next, we'll choose our network profiles, which dictate exactly where the database will live on the network once provisioning is complete. Moving on to the database server VM attributes page, we'll select our software profile, which contains the operating system and database templates customized for your environment. Next is the compute profile, which defines the vCPU and memory allocation for our database server VMs. The server names will autofill based on the cluster name we set on the previous page, but you can easily customize them as shown here. You can also scale out and add more servers to the cluster if needed. The minimum requirement for HA is 3 servers, which is exactly what we'll use for this demo. Finally, we'll designate the server as the primary, add our SSH key, and click Next. Now we'll configure our InnoDB cluster by entering a cluster name, admin username, and password. You can also install the optional MySQL router on this page to unlock additional functionality if needed. On the instance page, we'll set our instance name, the initial database name, the root password, and the database parameters profile. To review these specific parameters, just hover over the eye icon. You can also change the listener port and the initial database size right here. On the Time Machine page, we'll select our SLA. If you have an object store registered with NDB, you can select an SLA that includes log backups. We'll also define the time of day we want our snapshots to run, and how many full database snapshots we want to take per day. On the final page, if you're running the enterprise version of MySQL, you can easily enable MySQL transparent data encryption. With everything perfectly configured, let's click Provision. Now, let's head over to the Operations page. Using the classic cooking show method, I already kicked off and completed a provisioning operation earlier. If we open up the task details, you can see that it took under 15 minutes to fully provision this complete MySQL HA setup and have it ready to roll. If you scroll down, you can inspect every single step NDB automated for us. Let's close this out, click on our database name, and head over to the Details page. Here you can see our 3 newly provisioned servers and confirm that they are all online. Scrolling down further, we can see the exact profiles used to provision the cluster alongside our time machine. One of the major new features added for MySQL HA databases is point-in-time recovery, as well as the ability to take on-demand full database snapshots. Let's click into the time machine to check this out. From the Actions menu, you'll spot an option for a log catch-up, but for now, we're going to take an on-demand snapshot. We'll select Snapshot, give it a custom name, set our desired expiration time, and hit Create. While that snapshot is processing, let's look at how point-in-time recovery works. We'll return to the Actions menu and select Restore Source Instance. On this screen, you can restore the database to any point in time where a snapshot exists. Because this database was just provisioned, we only see our baseline options. However, as log backups accumulate between your regular snapshots, you'll get a granular timeline allowing you to pick the exact minute you want to restore from. Once we select our specific time or snapshot, we click Restore. To prevent accidents, NDB asks us to confirm that we want to overwrite the current database with the recovered instance. We'll just type the database name into the window and click Restore. Switching back over to the Operations page, we can look at a restore I completed earlier. You can see the intelligent workflow NDB follows. It starts by restoring the primary database, then sequentially restoring and synchronizing the database across all secondary instances.
And that wraps up our video for today. As you can see, the new MySQL HA support in NDB makes deploying, protecting, and recovering complex database clusters incredibly simple. And this is just the beginning of what's to come.
Be sure to check out NDB and MySQL by heading over to nutanix.com/testdrive for your free test drive. Don't forget to like, subscribe, and leave your questions in the comments below.